So now let's look at how we can determine slope of a tangent line or the slope of a curve when it's described in polar coordinates. So recall that slope is dy dx. So we have no y's or x's in here, so we got to figure out how we can determine this. Now one approach might be to try and figure out some way to go back to Cartesian coordinates, but we don't want to do that because that may be hard or impossible in some cases. So can we just stick with it in terms of theta and figure out the slope? Well, turns out it's actually quite easy because any polar curve can easily be parameterized, and we already know how to find slopes for parametric curves. So recall that in polar, it's true that every point in polar space relates back to x and y by our conversion equations, right? X equals r cosine, y equals r sine. Now, when you're on a curve, these two things are not independent, right? The theta is determining the r, and it's determining it by some function, right? That's the idea. If we have some curve, r equal f of theta, so on r equal f of theta, this becomes a parameterization because you now have x and y described in terms of the variable theta. That becomes our parameter. So what we have is a theta parameterization. So now we haven't found slope yet, but this is the key first step, is that understanding that a polar curve can easily be parameterized, now we can find slope of a parametric. So what happens, remember that we know from before that dy dx should be the derivative of y with respect to the parameter, in this case theta, over the derivative of x with respect to the theta, the parameter theta. So that's what we already developed for parametrics. Now let's just apply that to what we know x and y are. Well, it's a product, right? X is a product of two functions of theta, and so is y. So they're both going to require product rule. So dy d theta, that's going to be f prime times sine plus f times cosine. And dx d theta, again, product rule. So f prime cosine. And then when I take the derivative of cosine, that's negative sine. So typically, we just write that out front. So there's our formula for slope. A little more involved because it does involve this parameterization. Now you could memorize this formula if you like, but it is just one more thing to have to remember. If you know that this is the polar conversion, which you already need to know, then you know you can just apply this idea from parametrics via parameterization. Okay, let's find the slope, say, of that curve, the cardioid that we looked at. So say r is 1 plus cosine theta. Let's find the slope of that curve at, say, theta equal pi over 2. Now, this is the f that I'm talking about, right? We're talking about being on some curve r equals a function of theta. So that's the function of theta. So slope f prime would be negative sine times sine plus the function 1 plus cosine times cosine. And then f prime, so negative sine again, times cosine. minus the function 1 plus cosine times sine. And specifically, we wanted to know what it was at pi over 2. So we just need to plug it in. It's all sines and cosines. Sine at pi over 2 is 1. Makes that easy. And cosine at pi over 2 is 0. So easy one to evaluate. So our slope at theta equal pi over 2, that's negative 1 times 1 plus 1 plus 0 times 0 over negative 1 times 0 minus 1 plus 0 times 1. So what is that? Negative 1 plus nothing over nothing minus 1, or a slope of 1. Now, does that make sense there, that came out to be 1? Well, let's think about our graph. We had this, we sketched this one. Remember, this was our cardioid. It started here at 2, spiraled here to 1, into the origin, back out to 1. So rough sketch looks like that. And we were interested at theta equal pi over 2, so right here. And 45 degrees, that seems somewhat reasonable based on my rough sketch there, that is a reasonable answer from what we did. So you can always get a sense in these problems by sketching the graph and think about what the slope would be there. And if you at least will know if the sine's right? We know that should be a positive slope. If this came out negative, then that means I messed up with those minus signs in there. So it's a good idea to, it also gives you practice at sketching these things, right? These polar curves are new to us, so any chance you get to make a sketch will make you more familiar with them and kind of cement those ideas.